Hello, hi Saion.
हाय आद्या दीदी. हाउ आर यू?
I'm good. आप कैसे हो?
मैं भी ठीक हूँ. तो आपने प्रैक्टिस करा द बिट वाइज लाइक बिट
या
बाइनरी नंबर टू.
टू इंटीजर्स हाँ
हाँ.
मैंने करा प्रैक्टिस.
हाँ. सो फिर टुडे वी विल कंटिन्यू विद द बिट वाइज ऑपरेटर्स.
Okay.
या सो आई विल शेयर माई स्क्रीन. कैन यू सी?
Yes, I can see.
Okay. So there are like 6 bitwise operators that we are going to see, and let's see them one by one. First is the AND bitwise operator. So what this does is this compares the two bits, and if both the bits are 1 in the binary form, then it puts 1 in the place. So let me just take an example like 6 and 3. So 6 binary number is all the zeros and 0110. So let's take a 4 digit binary number. Yeah, 4 bit binary number, right? So we have converted this into 4 bits now. And what it will do, it will compare two bits. So for example, it will compare 0 of this number and 1 of this number, and if both the bits are 1, then it will put 1, and if one of the bits is also 0, then it will put 0. So 0 and 1 we are getting at this place, so it is putting 0 as one of the bits is 0. Then 1 and 1, so it will put 1 because both the bits are 1. Next 1 and 0, one of the bits is 0, so it puts 0, and then 0 and 0 will obviously bring 0. So in the end, this is our 4 bit binary number 0010, and when we convert that into an integer, that will bring 2 for us. So this was the AND operator, which like compares the bits, and when both the bits are 1, then it puts 1, and if one of the bits is also 0, then it puts 0.
Yes, okay, understood.
Okay. So we got 2 in this. Then or what it does is that if even one of the bits is 1, then it will put 1. So over here 0 and 1, so it will put 1 because one of the bits is 1. 1 and 1, both the bits are 1, so it will obviously put 1. 1 and 0, so one of the bits is 1, so it will put 1. And 0 and 0, that will put 0 because both the bits are 0 and none of the bits are 1. So in the end, our 4 bit binary number will be 0111. So 0111 is 7. So when we do x or 3, we will get 7.
Okay, understood.
Okay. Next we have the XOR. So it will set the bit 1 only if like one of the two bits is 1. So basically when there will be 0 and 1, so only when there is one of the bits is 1, then only it will set 1. So like over here we have 1 and 1, so it puts 0 because
Okay.
whenever one of the bits is 1, then only it will put 1. So when we compare 6 and 3, when we do XOR, then we will get 0101 when when there was one of the bits was 1. So 0101 is 5. And basically or the normal or operation, that was our pipe symbol, what it did was uh, whenever one of the bits was 1 and when both of the bits were 1, then it put 1. But when in XOR, when one of the bits is 1 and uh, both of them are 1, then it will put 0. Is this clear?
Yes, yes, it's clear.
Okay. Next we have this is known as the NOT. So what NOT does is it like changes all the bits. It inverts all the bits. So when we use NOT on 3, then it will invert it and make it like this number 1 1, like uh, so many ones and then 0 0. So it makes all the
Okay,
zeros
it will
ones.
just change all the zeros to 1 and 1 to 0.
Yeah. So now if we through the normal way try to convert this binary number into an integer, it will bring a very big number. But actually, it will not the conversion of this number won't be just the normal conversion that we saw. There is a different type of conversion. Like there are many types of like binary numbers also. So they can be represented in one's complement, two's complement. So it's like very advanced. But for now, we just know that this number is -4, and minus because the first bit is 1 and 1 represents a negative sign.
Yes. Okay.
Okay. Next we have zero fill left shift. So what this does is it shifts all the bits to the left and adds zeros to the right. So for example, we say 3 left shift 2 times. So it will like take away 2 bits over here of the start and add 0 in the end. So it will add 2 zeros in the end and take away 2 bits from the start. So when we left shift 3, then we get 1100, as 3's representation is 0011. And when we left shift it 2 times, then we get 1100, as 00 is being added to the end, and that is 12.
Okay. Yes.
And then we have the signed right shift. So what this does is it just shifts all the bits to the right, and over here whatever is the first bit, its copy it puts in the start. So for example, the first bit over here is 0, so, and we are saying 8 right shift 2 times, so it will drop off these 2 bits and then add two zeros in the start or in the left. So it has added
Basically, the opposite of left shift, na?
in left shift it was basically that it was adding only zeros in the end, and in this whatever is the leftmost bit, that it will add in the start. So
Okay. Okay.
if we had
Understood.
1, so it would have added 1 in the start.
Okay.
Yeah. Next we have operator precedence. So operator precedence is like BODMAS. Like we have in maths we have BODMAS. Similarly we have
Yeah.
operator precedence in Python. So like over here parenthesis is at the top. So it will first do the operation 6 plus 3 minus, then it will do the operation 6 plus 3. So it will basically be 0 in this case. And then over here the multiplication operator has higher precedence, and then it will be added. So 5 into 3 15 plus 100, that will give 115. So here is the operator precedence table, and this is from the most importance to the least importance operator. So most importance is given to parenthesis, brackets and BODMAS. Then we have exponent. Then we have unary operators like unary plus, unary minus, and bitwise not. So like unary, like we have not seen the unary operator right now, but if we just try to do it, let me show you. If we say plus 6 or minus 6, so what this is saying is that this basically, like we have -6 integer in maths. Similarly, minus is the unary operator that is making this number -6. Then plus, what this is doing, this is saying that this is a positive 6 number, and not we already saw that it inverted all the bits and gave us the result.
Okay. Understood.
Yeah. So plus 6 minus 6 and bitwise not. Then precedence is given to multiplication, division, floor division, and modulus. So these are given equal precedence. Then equal precedence is given to addition and subtraction. And when there is equal precedence, then it like executes from left to right. So when we have like multiplication and division in the same operation, then it will execute from left to right.
Okay.
Then next precedence is given to left shift and right shift, and after that the bitwise AND, then the bitwise XOR, then the bitwise OR, and then we have these comparison operators: double equals, not equals, greater than equals, and all. And then we have the not, the AND operator, and the OR, and these are not the bitwise ones, these are the normal and OR that we use in the if statement and all. So over here, for example, addition and subtraction have the same precedence, and therefore we evaluate the expression from left to right. Like as I mentioned, that we evaluate from left to right. Similarly, over here, there's an example also where it is evaluating from left to right.
Yeah, okay.
Okay, so now we are on Python lists. So lists also, I assume that you have already done before.
Yeah, I have done before.
Okay, so we'll go through lists and tuples quickly, and then in sets we will have like something new. So a list is created like through square brackets, and we can give any type of values in it. And Python has 4 built-in collection data types, basically, which hold different items, and we can loop through these collection data types like tuple, set, dictionary, and list, which have different properties and are used in different cases. So this is how we create a list, and we can also print the list normally, and it will print the list with square brackets. Next, list items,
Yeah,
like we access the individual characters of a string through indexing. Similarly, we access the individual items of a list through indexing, and it starts from 0 and goes on. There's also negative indexing, so -1 will access the last element. Next, one thing is that lists are ordered. So whatever order we give them, they will retain that order. And tuple, the sets that we have, those are not ordered. So sets are different from lists as they are
okay.
not ordered. And lists are like changeable. Tuples over here
Mutable.
are not changeable.
Yeah,
Yeah. So list also allows duplicates. So we can have duplicate items in list also. So we can have 2 times apple, cherry, etc. And then to find out the length of the list, we use the length function and pass in the list, so it will give us the length of the list. And list items can be of any data type like string, integer, and boolean, and one list can hold different types of values also. Next, if we check the type of my list, we'll get this written class list. So this basically shows that there must be a class made inside of Python known as list, whose object is what we have created over here. uh,
okay.
are you aware with the concept of classes?
No, classes I don't know, I just know functions.
Oh, okay. Then we'll get back to this class list example later when we are on classes.
Okay,
Okay, so now we have the list constructor, so we can also construct a list through the list constructor without using the square brackets, though it's not used often, but this is also another way. So we will have to the list, we will have to pass essentially a tuple. So we are passing a tuple with different items, so it will convert that to list and will return the new list.
so in this basically we are typecasting a tuple into a list,
Yeah,
right?
we are kind of like typecasting a tuple into a list.
Okay,
Next we have Python collection. So what it told us on the top, that there are 4 types. Similarly, we have it's like briefly telling us the properties of all the 4 types. So list is an collection which is ordered and changeable, and it also allows duplicate members. Tuple is ordered but unchangeable, and it allows duplicate members. Set is unordered, unchangeable, and unindexed. So unindexed, basically you cannot access its items through indexing. and there can be no duplicate members. Similarly, in a dictionary, it is ordered and changeable, but there cannot be duplicate members. So in dictionary, like we have key value pairs, so there cannot be multiple key value pairs with the same key. Um, is that, yeah? So set is like it's giving us a note that set items are unchangeable, but you can remove or add items whenever you like. So you cannot change existing items, but you can remove or add items. In a tuple, it is strictly unchangeable. The whole tuple is unchangeable, so you can neither remove nor add items nor change any existing items.
Okay.
And dictionaries previously were unordered, but since Python 3.7 they are ordered. Next we are on accessing items, so we do that through indexing. So one will bring banana, and then we have negative indexing. So negative indexing starts from the last element. So -1 will bring cherry, -2 will bring banana, and -3 will bring apple. Next, like we had like a range of indexes in strings. Similarly, we can have a range of indexes in lists also. So over here we are saying to access the items from the second indexed item to the fifth indexed item, where fifth index is not included. So it will only include cherry, that is the second index, orange and kiwi. It won't include melon, that is on the fifth index. So this is not included.
Yes.
So the search will start at 2, that is included, and 5 is not included. And from the start, if we want, we can just give no start index. So it will bring apple, banana, cherry, orange, because on the fourth index we have kiwi, so it will just bring apple, banana, cherry and orange. Now when we have range of indexes, it returns us another list. So if you would see, we are getting this in square brackets. So when we are
Yeah.
so it's returning us a new list. Next, from 2, and when we give no end index, so from the second index it will take to the last item, that is mango. So mango will also be included. And then we can also have we can also access items, range of items through negative indexes. So -4 is orange, -1 is mango. Mango won't be included, so it will bring orange, kiwi and melon. Next, we can also check if an item exists in a list, like we did for strings, we using the in keyword. So we are checking if apple in this list, then if this value is true, if this whole thing will give us true, so it will go in and print yes, apple is in the fruits list. Now we are on change list items. So we can access list items through their index, and then we can change them to any value we want. So for example, we are doing this list 1 equals to black currant, so it is accessing banana and it's changing its value to be black currant.
Okay.
And also we can change a range of item values. So together we can change a range of items. For example, we have this list apple, banana, cherry, orange, kiwi, mango, and we see this list 1 to 3. So 3 won't be included. So 1 is banana, 2 is cherry, and 3 is orange. 3 won't be included. So banana and cherry we are changing to black currant and watermelon respectively. So now this list value will be apple, black currant, watermelon, orange, kiwi and mango.
Yes. Okay. Understood.
Next, you can also insert more items. So like for example, instead of this item, you wanted to instead of this banana, you wanted to add 2 items more. So in place of banana you wanted to add two new items. So what you could do, you can say 1 to 2, where 2 won't be included. So it's just simply replacing banana with black currant and watermelon. So in place of banana we are getting black currant and watermelon. If we tried to do like this list 1 equals to black currant watermelon, like if we try to directly change banana to black currant and watermelon, then what this will do, this will insert the whole list in place of banana. So as you can see, we see square brackets over here, meaning it is inserting the whole list in place of banana. Whereas when we do 1 to 2, then it is individually adding these items in place of banana.
Okay.
Now the length of the list will change when the number of items inserted does not match the number of items replaced. So when we are adding more items in place of like lesser items, then the length of the whole list changes. Like after this example, the length of the list was 4 and before it was 3.
Yeah.
And we can also insert less items than we want to replace. So for example, we want to replace banana and cherry, and we only want to replace it by one item, that is watermelon. So this will basically replace banana and cherry with watermelon. So in place of banana and cherry we'll get watermelon. So we're getting apple and watermelon, and the length of the list has reduced.
Okay.
Now we can insert items. Till now we were replacing items. Now we can insert new items also. So for example, we have this list which has apple, banana and cherry, and we want to insert on the second index watermelon. So it will insert there at the second index watermelon. So we'll get apple, banana. Apple is on the 0th, banana is on the 1st, and watermelon is on the second index, and cherry is on the 3rd index. So on the second index that we specified, watermelon has been inserted through the insert
Yes.
method. Next we have different ways of adding items. One way we saw was insert. Second way is appending. So the append method will always add the item to the end of the list. So we get apple, banana, cherry, and then when we append orange to it, in the end it will put orange, and when we will print the list we'll get apple, banana, cherry and orange. Next, insert, we already saw that we can insert at a specific index. Then we can also extend the list. So what extending does is this, when we, like for example, we have this list that has apple, banana and cherry. Then we have tropical, which has mango, pineapple and papaya. So what extending does is, when we say this list dot extend, it will add all the items of tropical into this list. So this list will now be apple, banana, cherry, mango, pineapple, papaya. Okay, and if we just try to
Yeah.
normally append instead of extend, as this will also add to the end, append function also adds to the end, so it will add the whole list instead of adding individual items.
Okay. Understood.
Okay. And next we can extend any iterable into a list. So for example, if we had a tuple, then also we could extend it into this list. So when we said this list dot extend this tuple, then it would give us apple, banana, cherry, kiwi and orange. So we can extend any iterable
So
into
it
the
will
list.
not come inside a tuple, like it will come normally inside the list.
Yeah, it will come normally
Yeah,
inside the
okay.
list. Now I think this tuple also has an extend method. So if we say this tuple dot extend and we say this list, then when
Then
I,
it will come in tuple.
yeah,
Right?
then it will come in tuple. Okay, so it's showing that tuple does
Okay,
not
does
have
not
any
have
extend,
extend.
as it is unchangeable. You cannot change a
Yeah,
tuple,
yeah.
so that's why it does not have any extend method.
Okay, understood.
Yeah. Next we can remove specific items also. So like this list dot remove banana, so it will remove banana from the list. So if there are more than if there is more than one instance of banana, then it will remove the first instance only. So for example, we have apple, banana, cherry, banana, kiwi, and when we say this list dot remove banana, whatever wherever it finds banana first, it will remove that uh, that that value from there.
Okay.
And if we want to remove from index, so if we have an index whose value we want to remove, then we can use the pop method. And what it will do, like we are saying 1, so it will remove banana from the list. If we don't give pop any value, then it will remove the last item, that is cherry, and we will have apple and banana left. So we have apple and banana.
Yeah.
So yeah, if you don't specify, then it will remove the last item. We can also use the delete keyword, so to remove a specific item. So if we say del this list 0, that is apple, so it will delete this item, and we will be only left with banana and cherry.
So is there any difference between pop and del? Like both of them remove the item from like the specific index, right?
Yeah, basically there is syntactical difference. Also, pop is used to remove specific elements, but del can also be used to remove the complete list. So it can entirely remove the list also. So now that we have deleted the entire list, when we try to print this list, we'll get an error as it won't find this list.
It does not exist now.
Yeah. So it
Yeah,
can be also
understood.
used to remove the whole complete list.
Okay, okay, understood.
Yeah. So that's the difference, that it can be used to delete the complete list. We can also use it for the purpose for which pop is used. And next we have clear. So basically this is very similar to deleting the list, but the thing is that it removes all the items from the list and only keeps the square brackets, that is the empty list. So it
So the
empties out.
empty list remains in clear, and in delete the whole list gets deleted,
Yeah,
right?
yeah. So it is suggested to always use clear, because after deleting, if you use the list, then your program will produce an error. Whereas when using clear, after using clear, your program won't produce an error when using the list. So it's always
Yeah,
advised to use
okay.
clear. Okay. So now we can loop through loop through a list also. So using the for loop, we can say for x in this list. So in x we'll get the value of each and every item of the list. So we'll get first apple, then we'll get banana, then we'll get cherry, and then each individual item will be printed. So we'll get apple, banana, cherry in separate lines.
Yeah, okay.
Next we can loop through index numbers also. So for example, we have this list apple, banana, cherry, and when we say range length this list, so length of this list is 3, and range is getting the value 3. So it will create a range type list that will contain 0, 1, 2, and first i's value will
Yeah,
be
so it
0.
will print these three
Yeah.
indexes.
No, we are saying this list I. So when i's value is 0, and then we pass 0 to this list, so we are indexing it to bring the 0th element, so it brings apple. Then i's value is 1, and we are in.
So it will go to the first
Yeah.
index.
Yeah.
Yeah.
If we just wanted to print the index, we could have done it like this without like passing I to this list. So this will bring us 0, 1, and 2.
Okay, understood.
Yeah. Next, we could also use a while loop. So, a while loop is different from a for loop. So, it will keep on looping until and unless this condition over here is false. So the
False. Yeah.
so for example, we have this list equals to banana, apple, banana, cherry, and I, we have a variable 0. So while I less than length of this list, so till I is less than the length of the list, till then it will continue executing this code. So we right now when I is 0, it is less than the length, so we'll print the element, this list, and we'll pass I to it. So this list 0, so that's apple, and we will print apple. Then we will increment I. Instead of I equals to I plus 1, we could have also used I plus equals to 1. So that will also do the same thing. Next when i's value is 1, it will check this condition once again. Now also this condition, in this condition i's value is less than the length. So when we it will print and it will increment, then it will be less, as i's value will be 2 and the length is 3. So it will print and it will increment, and when I is 3, it is not less, so it will break out of the loop.
So it will break the list. Yeah, understood. The loop.
Next we have list comprehension. So list comprehension is basically a very short way to loop through lists. So for example, we have apple, banana, and cherry. So what we are doing, we are saying for x in this list, right? And for x in this list, so it will get, in x we'll get each item of the list and then print x. So this syntax is pretty weird, but this is like in one line we have done the whole loop instead of using like 2-3 lines in while and for loop.
Yeah, okay. So it will work exactly like the normal list that we use, or like the normal loop that we use, just we have written it in a single sentence.
Yeah, and also this is used to, like, when we are working with very short loops, then we use this. When we have longer loops, then we have to use the normal loop, as this syntax won't work for longer loops. For one statement loops, it does work.
Okay, understood.
And next we have list comprehension in detail. So here we have an example of such a long code for basically like what this code is doing. This has a fruits list and a new list, which is an empty list, and then in x we are getting each fruit, and we are checking if the letter A appears in the fruit, then it appends that fruit to new list. And basically in new list, in the end we'll have apple, banana, and mango, as in these fruits the letter A appears, and in rest of the fruits the apple A does not. So when we print new list, we'll have apple, banana, and mango. Now for such a simple code, we had to write this 5-line this 3-line loop. So the loop is 3 lines, including initializing new list. It's around 4 lines, so we had to write 4 lines for this much code. Now using list comprehension, that whole 4 lines could be reduced down to 1. So what we are doing, we are saying for x in fruits, so x is bringing apple, then banana, then cherry, then kiwi, then mango, and then here is our if statement. If A in x, so it will check. If A is in x, then it will return the value of x to be saved in this new list. So whenever A will be in x, we are saying x over here, which is basically saying to return the value of x to save in this new list that will be created. So when we print new list, we will get apple, banana, and mango.
Okay. So basically, even if we write 4 lines of code for this, it's not wrong, right?
Yeah, it's not wrong, but when we are coding a lot and we have very big programs, then we to make it more cleaner and readable, we have to shorten our code. So for that, list comprehension can be done to reduce the number of lines of the code.
Okay, understood.
Next, this is the syntax for it. So it's basically saying that for item in iterable, you write over here, then you give your condition, and then finally the expression that is to be executed if the condition is true.
Yeah.
So the condition is like a filter that only accepts items that value it to true. So if the, like for example over here in this case we are checking if x is not equals to apple, then put x in new list. So it will only put banana, cherry, kiwi and mango, and it won't put apple.
Okay.
And then if there is no if statement, this is the most basic list comprehension. So for x and fruits we loop, and we are putting x, we are returning x to be added into the new list. So when we print new list, we'll get apple, banana, cherry, kiwi and mango.
Yeah. Okay.
Yeah. And over here just a recap of another concept. When we check new list is equals to fruits, then we will get true. But when we check if it is fruits, then we'll get false.
And we use false. Yeah.
Next we can also, like we have normally an iterable when looping. If we don't put the list but we say like range 10, so this will produce an iterable which will have numbers from 0 to 9, and then x, each time x value will be one of those numbers. So first it will be 0, then 1, then 2, then 3, then 4 and so on till 9, and each number will be returned to be saved in the new list. So we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah. Okay.
Next we can also say we can also have an if condition. So whatever range produces, whenever the x value is less than 5, then only add x into the list. So less than 5, so it will give 0, 1, 2, 3, 4.
Yeah. Okay.
Yeah. Next we have an expression over here. So we could return any value. For example, for x in fruits, if we don't want to, we were till now returning x. For example, we returned high, so it would have added high 5 times. Now
Yeah, this is the amount of time the loop works, right?
yeah. Now if we do x dot upper, then this will return the value of x in uppercase. So it will return apple, banana, it will show us apple, banana, cherry, kiwi, mango, but now in uppercase.
Uppercase. Yeah. Okay.
Yeah. um yeah, like over here the hello example also, it will loop through the list but we can return any value we want.
Yeah.
Now when we don't only have the if statement and we have the if else statement, so when we have both if else, then what we do, the for loop shifts to the right, then we have the if statement over here, then the else statement, and then the return.
And then follow.
Yeah.
Yeah.
So if x is not equals to banana, then it will return x, else it will return orange. So it will give us apple, orange, cherry, kiwi and mango.
Yeah. Understood.
Next we are on list sorting. So sorting is a long chapter and we have 1 minute left in the meeting, so we can continue tomorrow.
Okay. Thank you.
Thank you. Bye bye.
Bye.